Okay, perfect. So now we're looking at case 2 on functions, and case 2 deals with equations, right?
Yes, sir.
You'll be given a function like before the question, and then they'll say, find the value of x if f of x is equal to something. So there's a clear distinction between case 1 and case 2. In case 1 type of question, we didn't have this equal sign. But in case 2, we have an equal sign.
Yes, sir.
So this is how we're going to do this one. The first step is to write your original function. So they're saying f of x is equal to x squared plus 4. And then in the question, they are saying f of x is equal to 20. So you can see that we have two f of x's, and we have different values for each one of them. So what we can do is we can say green equals red because f of x is just f of x. So let me do this. So the red f of x is equal to the green f of x. And the red f of x is x squared plus 4. And since it's f of x, it's going to be equal to the green f of x, which is what? 20, isn't it?
20, sir. Yes, sir.
And then once you're here, you just need to solve your equation. So we take this to the other side. We have x squared equals 20 minus 4. X squared equals 16. So therefore, x is the square root of 16, which is plus or minus what? 4.
Yes, sir.
Okay. So I know you know how to solve the equations, so we're not going to dive deeper into that. But your key takeaway from case 2 is this section. You have two expressions, two values of f of x. So you're just supposed to equate them and then solve the resulting equation.
Yes, sir.
Okay. So I don't know if you have any questions on case 2.
No, sir.
All right, perfect. Because we want to try and finish everything, and then we'll do maybe a past paper type of question with all these
Okay.
cases.
Sir, so what I'm getting from the second case is that you wouldn't take 20 and put it into the first f of x is equal to x squared plus 4. You would take them and then put them sort of together because they both equal to, and then you would take their values and solve it.
Yes, that's correct.
Okay, sir.
Okay, perfect. So let me just do a print screen here, but there's no need for it since we're recording the video. Okay, so that's case 2. Now we need to move on to case 3.
Sir, may I quickly go get a glass of water?
Yeah, you can.
Thank you, sir. I'm back, sir.
Oh, perfect. That was quick. So now case 3. Now case 3 is more like case 1. It's just composite function. So under composite function, you'll be putting a function inside another function. So we can write a function inside a function. Perfect. So I'm going to illustrate that with an example. So this is the most common type of question, like in the exam. Let's do it this way. Our example. So given that f of x is equal to, let's just say, x squared plus 2x. And in this case, you won't be given just one function. You'll be given two functions or more. Okay. So since you're going to have another function, they won't use f. So they'll just give you something like g of x, isn't it?
Yes, sir.
I just write it as 1 over x. So we have two functions, f of x, and we have g of x. And this is the nature of the question. So find a f g of x, and then b g f of x. All right, so that's fine. Let me make it bigger. Okay, so let's start with the first one. All right. So the most important thing here is to look at the question you are given. We have f on the left-hand side, and we have g on the right-hand side, and then we have x. So our substitution should be done from the right going to the left. Remember in case 1, when we were doing something like f of 2, f of 3, you were putting 3 in f, or substituting 3 in f, isn't it?
Yes, sir.
So in the same manner, what's on the right must get into the parent function, which is on the left. So in this case, let me make it easy for you. We are going to take g and put g into f. So moving from right to left, isn't it?
Yes, sir.
So I'm going to write our f of x, because this is the parent. It's x squared plus 2x. Now I'm going to sub in the g so that we have f g of x, because g is the child. So what is our g of x? Is 1 over x, right? This is our
Yes,
g
sir.
of x. So we need to plug it in f of x everywhere, there and also there. So our
Okay.
final function will be 1 over x squared. G is taking the place of x. No, maybe I should just use blue for g. So that's g. And then plus 2 is part of the f function. Now we need to replace that x with what? With the blue. All right. So now we might need to simplify this a little bit more. So this 2 can actually be applied to everything, to the fraction. So it will be 1 squared over x squared. And then if we multiply that bracket, we're going to get 2 over x. Are we together?
Yes, sir.
And then the final answer will be 1 over x squared plus 2 over x. So this is the final answer. Again, it might seem confusing, but just know that the one on the right will always get into the one on the left. You always substitute the one on the right. Are we together?
Yes, sir.
Okay. So when we do practice, you're going to enjoy it more. Let's look at the second question. All right. In this case, we need to find gf of x. F is on the right, so F must get into G. So our G of x is equal to 1 over x. But we need to put F in this G of x, isn't it?
Yes, sir.
So this is what we're going to do. Gf of x is gonna be 1 divided by, and then in place of this x, we're gonna put our f of x, isn't it? The child.
Yes, sir.
So it will be 1 over x squared plus 2x. And that's the final answer. We can't really simplify it anyway. Can you see what has really happened here?
Yes, sir.
It's just substitution, but the key takeaway is that the guy on the right will always get into the guy on the left-hand side. So this is what we call composite functions. It's similar to case 1, but here you won't be given like single values. You'll be given like other functions.
Yes, sir.
For your substitution. All right, so that's it. And bear in mind that you can have a hybrid case where you have this case 3 and then case 2 again. They might say find gf of x is equal to 2. So you need to find gf of x first, and then you equate it to 2, and then you solve. All right. That's fine. Let's just look at the last case, case 4, the inverse. And then from there, I think we're gonna use the rest of the minutes to look at some papers. All right, I think I should just do this. Can you see this page?
Yes, sir.
Okay. All right. So now we need to look at case 4, the inverse of a function. Okay. All right, let's do this. So for you to find the inverse of a function, there are a few steps that you need to follow. Steps. Step 1, write the function. I just write in y form. So we don't want to see f of x there, isn't it? You replace your f of x with y.
Y, sir.
It's just gonna make it easy when you are doing your calculation. Instead of just
Okay.
using f of x, remember, is like 2 letters already. And we're going to be doing a change of subject, so it won't make sense to have this. Okay. And then step 2, make X the subject. Okay. And then step 3. For step 3, you must switch your values. All your X's must be Y, and all your Y's must be X's, doesn't it?
Okay.
So flip the letters. I think there's an easier way. Flip the letters. Okay, so an example will actually make it easy for you to understand. And remember, an inverse of a function is denoted by this, f of x to the power of -1, right?
Yes, sir.
Okay, so let's look at this example. Given f of x is equal to 3x plus 7, find, sometimes they won't say find the inverse, they just say find f of -1 of x. That's the inverse. So this is our solution. Make it slightly thicker. Okay. So our solution. So for step 1, we write the function in the y form. So y equals 3x plus 7. That's step 1, right?
Yes, sir.
And then step 2, what are we supposed to do in step 2?
Make X the subject, sir.
Okay, perfect. So I'm simply gonna make x subject on the right. So y minus 7 divided by 3 equals x. I know you understand this, so I won't spend much time on this.
Okay.
That's step 2. And then
Yes.
step 3,
Flip the letter, sir.
perfect, which means your y is gonna be your x is gonna be your y.
Okay, sir.
So now we have x minus 7 over 3 equals y. So that's step 3. And this is your inverse. Your new y is your inverse. So in other words, we are saying f of -1 of x, the inverse of f of x is x minus 7 over 3.
Okay, sir.
Okay, so Lisa's just trying to call. Let me see. All right, so I'm just gonna tell you that I'll upload the video and then give you the link.
Okay, sir.
Okay, perfect. So we're left with 10 minutes. I think that's fine. We can use those 10 minutes to look at like a typical past paper. So these are the 4 general cases that you must be aware of when you're dealing with functions. So functions in a day, we are done with them. All what's left is practice maybe for 2 days and then you'll be okay. Because I know you know how to make to change the subject, and I know you know how to do substitution, and I know you know how to solve equations.
Yes.
So now you have the background. There's this paper that I gave you, which had functions. Do you have it with you, or let me see. It was a past paper I printed out, like past paper. And then I asked you to attempt all the questions you can. Let's see if I have something like that.
So is it the May-June one for
Yeah.
2021?
Yes.
Yes, sir. I still do.
All right. So let me quickly download it again. It's May, June 2021. Okay, it's fine. Do you know the code? I'm just heading to save my exams. Past
So
papers.
wait, 50580-41.
Okay, May, June 2021, and it was paper 4, right?
Yes, sir.
Okay, so let me just re-download it and open it. Functions are all over, so
The functions questions start from page 18, sir.
okay. All right, so it's fine. So I just want to show you quickly how we do this one. And yeah, in 7 minutes, we should be done. So this is a typical function question, and in most cases, it will be just the same. And they are going to give you all the cases. So I'm sure you can identify that part A is case 1, it's simple substitution. And I'm going to do
Yes,
it
sir.
for you. So we have f of x, g of x, and h of x. Those are 3 functions, but we'll be just using what we need at a time. So in this case, this is case 1. So f of -5 is going to be a simple substitution. We're going to write our f of x, and then let me do it here so that it will be easier to follow. So f of x equals 3 minus 2x. Then f of -5, we simply substitute -5 and put that in place of x. So it's going to be 3 minus 2. Then in place of x, we're going to put -5. And then I don't know what we're going to get there. Yeah, it has to be 13.
Yes, sir.
Perfect. So easy stuff, simple substitution. That's case 1 for you. Now,
Yes.
this looks like case 2. Oh, case 3, maybe composite functions, a function inside a function. So
Yes, sir.
that's case 3, according to our notes. But really, you don't even need to claim like the cases to understand like which one is case 1. It was just meant to make it easier for you to understand. So this is the third case. So f of x, we are supposed to put f in f, isn't it?
Yes, sir.
F is the child of f. So I'm going to write 2 f's here. So the blue f of x is 3x minus 2x. And then the parent, I'm going to write it in red. It's 2 f of x again. It's 3 minus 2x. Let me remove that other extra x, isn't it? So it's just the same function.
Yes, sir.
So the blue must get into the red. So our final answer, f of x is gonna be, I'll write the red first, 3 minus 2, and then in place of that red x, I'm gonna put my blue function. And my blue function is 3 minus 2x again, isn't it?
Yes, sir.
So now we can simplify this. So 3 minus 6 plus 4x. And then our final answer is going to be what? minus 3 plus 4x. All right, any questions on this one? It's pretty tricky because we're using the same function. Put the same function in itself.
I think with more practice, I'll be able to get it, but
Sorry, you're breaking.
so I said I think with more practice I'll be able to master it, but I get it, sir.
Yeah, it's just a matter of here. What makes this thing complex is you have different functions. It was gonna be easier if you have different functions getting into each other. Right now, you have the same function getting into itself. So if you had something like this, y equals 3x. Okay, let's do this. If you had something like this, f of x equals x squared, and g of x equals 2 over x cubed. Then finding f g of x is gonna be easy. We are putting g in f, right? So
Yes.
our f is red. I'm gonna write it in red. So it's 2. Our f is red. We can't even write anything on f because it's just x squared. Let me just make it 2x squared like this. Okay. So our f is blue. I'm gonna write the parent, the blue part first. So that's 2. But I won't write the x component because I need to replace it with g, isn't it?
Yes, sir.
So I'm gonna take my g and replace this x guy. So in place of that x guy, I'm gonna put the g 2 over x cubed. And then on the outer function, I'm gonna put squared like that. So this is the guy from the parent. That's the guy from the parent. But the middle part here has been replaced by g because it's an x component.
Yes, sir.
All right. So with time, you can just revisit this video and then you get the hang of it.
Okay.
All right. So we're left with less than a minute, but for part C, it's gonna be easy. You just need to write your g of x, your f of x, and then you solve. So g of
Okay.
x is x squared plus 5.